Service mesh, a dedicated infrastructure layer for service communication. Agenda, microservices communication. Service mesh history. Via service mesh, request lifecycle. Getting started. Basic workflow. Data plane and control plane. Microservices communication. As an application splits into many independently deployed services, those services need a reliable way to discover, call, and secure connections to one another. If a request fails partway through a chain of services, consistent retry and timeout behavior keeps one bad call from cascading into an outage. Almost every organization running microservices eventually needs a consistent way to manage traffic, security, and visibility between services. Any team operating dozens or hundreds of services benefits from handling these cross-cutting concerns in one place. Solving networking, security, and observability separately inside every service doesn't scale. Application level and infrastructure level networking. Application level networking bakes retries, timeouts, and security directly into each service own code or shared libraries. Infrastructure level networking provided by a service mesh moves that logic out of the application and into a dedicated layer. Application level client libraries, custom middleware, duplicated per service. Infrastructure level service mesh outside the application, consistent everywhere. Problems without a dedicated communication layer. Single point of failure, inconsistent retry and timeout logic across services lets failures cascade. Every language and framework ends up with its own separate implementation of the same networking concerns. Encrypting traffic between services means managing certificates by hand, service by service. Hard to see how requests actually flow across dozens or hundreds of services without dedicated tooling. Rolling out a security or reliability fix means touching every single service code, misses out on consistent centralized policy for security, routing, and observability. Service mesh architecture, traffic and security policy are declared as configuration and kept in a source or Git repository. A data plane of lightweight proxies sits alongside every service instance, intercepting its network traffic. A control plane distributes configuration to every proxy and keeps the mesh's actual behavior in sync with policy. Well-known service mesh implementations: Istio, Linkerd, Console Connect, Cilium. Service mesh advantages: adds retries, timeouts, and circuit breaking without changing a single line of application code. Encrypts service-to-service traffic automatically, often with mutual TLS. Enables fine-grained traffic shifting from canary releases to progressive delivery. For canary releases and progressive delivery. Gives deep observability into service traffic through metrics, logs, and distributed tracing. Centralizes authorization policy instead of scattering it across every service. Works consistently regardless of which language or framework each service is written in. Everything is observable, almost. One huge benefit is that in a service mesh, almost every request passing through the data plane is measured automatically. Golden signals like latency, traffic, errors, and saturation are collected, for every service without instrumenting application code. Distributed tracing follows a single request as it hops across many services, showing exactly where time is spent. Dashboards can show the mesh's entire topology, service by service, purely from proxy telemetry. This visibility turns which service is slow from a guessing game into a quick lookup. Sidecar and sidecarless models. Sidecar: a proxy container runs alongside every single service instance. Sidecarless: a shared per node proxy or eBPF program handles traffic for every pod on that node. Traffic policy.yml: a generic traffic policy adds automatic retries and a timeout to calls between two services. Authorization policy.yml: a generic authorization policy allows only a checkout service to call inventory. History: the term service mesh was popularized around 2016 by William Morgan and the team building Linkerd at Buoyant. Linkerd 1 shipped in 2017, drawing on ideas from the internal networking layers big tech companies had already built for themselves. Istio, backed by Google, IBM, and Lyft, launched the same year and quickly became the most widely discussed implementation. The pattern matured through the late 2010s as Kubernetes made sidecar injection and dynamic proxy configuration practical at scale. Newer sidecar-less approaches using eBPF like Cilium's emerged in the 2020s to reduce the resource overhead of a proxy per pod. Why a service mesh? Consistency: the same traffic, security, and observability policy across every service. Security by default: automatic encryption and identity between services. Progressive delivery: fine-grained traffic shifting for safer releases. Deep visibility: metrics, logs, and traces for every request without custom instrumentation. Language agnostic: works the same whether a service is written in Go, Java, or Python. Backed by a large, active open source ecosystem across multiple implementations. The sidecar proxy. A sidecar proxy is a small, dedicated process deployed alongside each service to handle its network traffic, intercepts inbound and outbound traffic transparently without the application knowing it's there, enforces policy locally so decisions don't require an extra network hop to a central service, never route traffic around the sidecar. Doing so silently bypasses the mesh security and policy. Service mesh request lifecycle. Sends request, client sends request, proxy intercepts traffic, policy applies rules, upstream reaches service. A request leaves the client, is intercepted by the local proxy, violated against the mesh's policy, and finally reaches the upstream service. Getting started with a service mesh. This leads us to the three steps that bring a cluster into a mesh. Choose an implementation. Pick a mesh that fits your platform and team. Install the control plane. Stand up the components that manage the mesh. Enable sidecar injection. Add services to the mesh one namespace at a time. Basic workflow: deploying, observing, and securing. Some call deploy, observe, and secure a service mesh everyday loop. Declarative: reapply the same policy and the mesh only changes what's different. Dashboards give an instant view of every service health and traffic. Traffic shifting rules take effect within seconds of being updated. MTLS, mutual TLS, and authorization policy can be tightened gradually, service by service. Supports many workflows, canary releases, zero trust security, multi-cluster networking. Works the same across any platform the chosen mesh implementation supports. Any questions? Thank you.